Hey everyone, it's Professor Lamb, and we're going to do a walkthrough of Module 2. So the first assignment is a binary search problem. We're going to complete the implementation for two methods. And the first one is a sequential search, and we're trying to see if this array of stolen card numbers contains this search card number. So the idea is, if this search card, let's say it's your credit card, if your credit card number is found in this collection of stolen cards, it means your card has been stolen. That's kind of what this program is for. It's a stolen credit card checker. So let's do the simple sequential search version first. And for sequential search, we just need to iterate through every element of the array and check and compare each and every element to see if it matches the search card. So we can use a for loop for that. For each number of stolen cards, this is again the enhanced for loop, which is a bit simpler than dealing with the index counter variables. So if that credit card number equals search card numbers, we should just be able to break out of this loop and return true. Otherwise, we'll return false. And that's really it. Again, kind of the point of this exercise is that while this is very simple code, it's not actually the best code because it's not the most efficient. This would take a long time to compare each and every card in a big array with a search card. So let's see if there's a more actually efficient in terms of performance way. And indeed there is. It's called binary search. So we're actually going to write pretty much the exact same method in terms of method signature, but the implementation is going to be completely different. This time we're going to use an algorithm. And it says first we want to create 3 variables to represent index values. And again, if you did the reading, you'll realize that binary search is kind of intuitive, and it does have some assumptions. It requires that the array is sorted, and I actually take care of that for us. Yeah, so we're not worrying about sorting the array here, but it is a precondition of a binary search algorithm, which will probably be in these comments. Starting index 0, and it's going to be the size of the array minus 1. And then we're going to want to set the middle int within a while loop. And this is all in the textbook. It's confusing, but we want to keep this loop running until the start index is greater than the end index. So you can think of it as a two-winged approach here. The start index is going to keep increasing, end index is going to keep decreasing until we narrow it down on the search term. So let's create let's just call it mid. It's going to be the middle index value. And to get, how do we calculate middle index, especially if these two variables, start and end, are going to keep changing? We want to add them together and then divide by 2. So even if start's not at 0, this will work. And for order of operations, we need to put some parentheses there. So let's check. Let's deal with the logic. What will happen? Let's say we got lucky in our first mid guess. Let's say we guessed 50, from 1 to 100, and then the search card is 50. Let's deal with that first. In that case, we can break out of this loop early and return true. Otherwise, we're going to check if the value at the middle is higher or lower than our guess. This is going to be a if else. Okay, so what should we do if our guess is lower than the search card number? We want to change. We want to increase the start index to mid. But if we just did that, it would create an infinite loop, and the start index would never actually be greater than the end index. So we actually bump that up to +1. And this is kind of tricky, but yeah, the textbook covers it well. And let's do the opposite. If our guess was higher than the search card. And we need to return this will keep iterating, and eventually, once the start gets raised higher than the end, if mid still hasn't found, if we still haven't found a match yet, we need to return false. And that is binary search in its simplest form. Let's just run this code, make sure everything works. You should see binary search being a lot quicker. Sequential search. Alright, so it looks like everything works, and this is kind of my hidden test. I secretly planted the search card in the collection, so your answer should be true. That's kind of how I'm going to test your code. And we do see that binary search, we took 2300 nanoseconds, which is like 0.0000 seconds. It's very fast on my computer. Your number is a little bit different, but binary search algorithm is almost 300 times faster than the sequential search algorithm. So Yeah, algorithms can make a big difference in terms of efficiency. Okay, and now for part two of the module 2 assignment, which is in the generics package. We are going to complete a pocketbook application. And you've already read the instructions and watched the video on the assignment page that goes over JUnit. If you want to practice test-driven development, you would actually run this file first and see if the tests fail like we're expecting them to. So run as JUnit test. Interestingly, a few tests pass, like test not full. Which usually means the stub method that's already in Pocketbook returns false. So this method probably already returns false in Pocketbook, even though it's not. It's just hard coded. The correct implementation isn't there. But most of these tests are failing. So let's see if we can get them to pass. First thing I'm going to do for this application is create a static variable which will help us keep track of how many items are in the Pocketbook. And the reason we want to do that is because in Java, when you create a new array, the array size will show up as whatever you set the capacity as, even if it's full of null values. Even if you haven't put any items in the array, this array that we create will still have a length of 10, even though we haven't added anything to it. It's including the null values. So we need some way to actually count the number of items we put into the Pocketbook as we put them into it. And this can be a static variable because it's going to be used for the whole class. The way this is set up, you probably wouldn't have multiple Pocketbooks. But I guess it's a possibility. So let's not make it static. Let's just make it an instance variable here. Call it item count. And get type. And the new Pocketbook is constructed. We can set this to 0. When you get a new Pocketbook from the store, let's just assume there's nothing in it yet. Then, so we're going to need to increment that item count and also use it to fill up our Pocketbook. So let's try this. This should work for our purposes. Is empty. We can just use our same field. 2 and count if it's at 0. There's no items in the pocketbook yet. This method's really straightforward. We're just returning item count field. And this full is going to be straightforward too. Pretty much exactly like this, except I want to set this to the size of the array. So let's do it. Do the easiest ones first. Save contains for last. I think empty out. We could just create a new pocketbook, but what I want to do is try to mimic the real world. So in the real world, we would set each item. We would null out each place. So let's do that. For each thing in the pocketbook, set it to null. And then reset item count to 0. You could do that a different way, but it doesn't really make sense in the real world to buy a new pocketbook and try to reassign it. So we'll just go with this. And now we have our iteration code, which we can use. Alright, and we should be able to reuse that iteration code here as well. And I'm going to do quality by test for quality by reference. We don't need to use the equals method. These items would actually refer to the same object in memory in the heap, so that's one that we can use. The reference equality there. Okay, that's pretty much it for the first part. Let's see if our test pass. And we can see if this code runs first. And null pointer. Yeah, kind of makes sense. So print all items. It's printing out nulls. So we can easily fix that. This is actually the recommended way to check for nulls. to print out a field instead of an actual. Maybe we have it underneath. Let's see what we can get. This is our, this is a method that all carryable objects, all objects that implement the carryable interface are implementing this custom method called identify, which should print out. So we might not even need a system print here. We might just do it to identify. Yeah, there we go. And when we run JUnit tests, right now 10 failing. And now they'll pass. It's always a good feeling. So the last part of this assignment is we're supposed to create 3 more pocketbook items in this file that that implement the carryable interface, just like this. So we should be able to just copy and paste. So we aren't going to want to copy and paste. It'll be easier. I'll show you the minimal code necessary for this. Of course, we need some lipstick. And all we need to do is implement character. Okay. So this is an empty class right now, but since it implements the carryable interface, if you hover over that error line, you can just fix it by saying add on implemented methods. There's that identify method we talked about previously, which should just print out that this is a file. It's binary. You don't need it. This is kind of overkill. But you could put the name of the class. So, okay. This says this is a string template here, and this first string refers to this field. So a key is either a house key or a car key, and that will go in this first template position. And then this code just gets the class name key. So this will print out this is a house key. That's all it does. But just to show you how to use this code, this is a useful method we'll often know about. This is a string concatenation. There we go. And then you'll need to create 2 more classes. You can name them whatever you want, and they just need to print out. This is a cup. This is a coin. You don't need to use this code, but you can if you want to. And then you need to add lipstick to our main method right here. There's no parameter. Let's see if that worked. There it is. So that's the minimal code. Again, you need to do that twice, 2 more times. Or if you don't use lipstick, you can do it three times total, and just add those classes here. This is just a learning exercise. So I created a item called rocking chair, which does not implement carryable. So let's see what happens if we try to add rocking chair. And it won't even let me run the code. Because rocking chair doesn't implement the carryable interface. What happened in Pocketbook just for keys? Yeah, so it kind of shows you how generics work. Instead of having a Pocketbook full of items, you could have a Pocketbook that just accepts keys. That's valid code. And that is it for our module 2. Let me know if you can assist in any other ways. Thanks, everyone.